Today we'll be learning about the remainder theorem. Okay, we'll learn about the remainder theorem. Okay, it is a very easy theorem and it is our last topic of this, last subtopic of this whole topic, which is factors and polynomials. Okay, so we'll just understand what remainder theorem exactly is. So we'll just understand it through the help of an example. Okay, so suppose you have a function as fx is equals to 2x cubed minus 4x squared plus 7x minus of 37. Okay, you have this function and you have to divide this by x minus 3. Okay, you have to divide this function by x minus 3. So we'll just perform the long division method. So 2x cubed minus 4x squared plus 7x minus 37. Okay, we'll divide this by x minus 3. Okay, so what will be your quotient here? So x multiplied by 2x will be 2x cubed, and here you'll get minus 6x. So we'll write, okay, wait, this is cube, so 2x square, sorry. So x multiplied by 2x square will be 2x cube, and minus 3 into 2x square will be minus 6x square. Okay, so you will just reverse the signs, so this will be equals to 2x square, and 7x will come downwards, so 2x square plus 7x. Now x will be multiplied by 2x to get 2x square, so 2x square minus 6x. Okay, reverse the signs. So what will be your answer? Your answer will be 13x. Now minus 37 will come here, so 13x minus 37, so x plus 13, so 13x minus 13 threes are 39. So when you'll just reverse the signs, what will be your answer? Your answer will come out to be plus 39 minus 37. So okay, I'm writing the answer over here. So when you perform the division, your answer will come out to be 2. Okay, so your remainder will be 2. Okay, so we can see that the remainder here is 2. When we'll multiply fx by x minus 3, our remainder will be 2. So when we perform such divisions, like when we perform just normal divisions, so what we write, dividend is equals to divisor into quotient plus remainder. This is how we write the dividend. So here we'll write it like that only. So dividend is fx, which is your cubic polynomial. Okay, fx is equals to divisor. What is your divisor? Your divisor is x minus 3. What is your quotient? Your quotient is 2x square plus 2x plus 13, and your remainder is 2, so plus of 2. Okay, so whenever we are performing any division, so we write like this. Okay, so in general we can say that when any polynomial px is divided by x minus c, okay, okay, so when any polynomial px is divided by x minus c to give the polynomial qx. Okay, so qx is your quotient. Qx is your quotient. Okay, so whenever we are dividing any polynomial by x minus c, so you get the quotient as qx and you get your remainder as r. Okay, so then we can write that the polynomial px is equals to divisor, which is your x minus c, into quotient, which is your qx, plus remainder. Okay, so this is your form, which you have learned earlier also and which you know now also. Okay, now if we substitute the value of x is equals to c in this equation, if we substitute the value of x is equals to c, if we put x is equals to c in this, so what we'll get, p of c is equals to c minus c into qx, c minus c into qx plus r. So this whole term will be 0. So p of c will be equals to r. Okay, so now this is our remainder theorem. This is our remainder theorem. So the thing is that when we put the value of c in that polynomial, we'll get our r remainder. Okay, so this is a remainder theorem. So what is basically happening here? What is basically happening here is that when a polynomial px is divided by x minus c, then our remainder is p of c. Okay, this is your remainder theorem. When any polynomial px is divided by x minus c, then our remainder is p of c. Okay, and this remainder theorem can be extended, like if any polynomial px is divided by ax minus b, then our remainder is p of b upon a. Okay, so you just have to remember these 2 points. Okay, we'll discuss it with the help of an example also, so that it will be more clear, but you just have to remember these 2 points. When px is divided by x minus c, your remainder is p of c. Okay, so when you put the value of this function x is equals to c in px, you'll get the remainder. Okay, and now when you'll put the value of x is equals to b upon a in this equation px, so your remainder will be p of b upon a. Okay, so we'll just solve one question so that it is more easy for you to understand. Now suppose you have an equation 7x cubed plus 6x. Okay, we'll just a second, I'll just write it a little below so that it is easier for you to perform the long division. Okay, so suppose you have the polynomial 7x cubed plus 6x square minus 40x plus 17. Okay, when this is divided by x plus 3, so you just have to find the remainder first by algebraic method, which is your algebraic division. Okay, so you have to find the remainder. You have to find the remainder by algebraic division first, and then by the factor theorem. Okay, so by algebraic division, we can simply calculate the remainder by simply dividing it. So this is your first part. When 7x cubed plus 6x square minus 40x plus 17 is divided by x plus 3, what we'll get? What will be the quotient here? First, we'll take 7x square. So here it will be 7x cubed plus 21x square. Okay, you just reverse the signs. Minus, minus. So here, what will be? What will be the answer? It will be minus 15 x square minus 40x. So here minus 15x. So here minus 15x square minus 45x. So here after reversing the signs, you will get 5x plus 17. So x plus 5x plus 15. So what will be your answer? Your answer is 2. So by algebraic division, your remainder is 2. Okay, by algebraic division, your remainder is 2. Now the second part is that you have to find the remainder using factor theorem. Okay, you have to find the remainder using factor theorem or by this remainder theorem. Okay, so what we'll just do, see, factor theorem and remainder theorem are just, extended versions of each other. Okay, it is all related. So when you have to find the remainder by factor theorem, it is a very simple method. We know that fx is equals to 7x cubed plus 6x square minus 40x plus 17. Okay, and we have to divide it by x plus 3. So we'll just find out the value of x by equating it to 0. So x is equals to minus 3, and when we'll put x is equals to minus 3 in fx, you'll get the remainder. So f of minus 3 is your remainder. F of minus 3 is your remainder. So this is defining your remainder by the factor theorem. Okay, so when you will put f of minus 3 in this, so what you'll get? You'll get 7 of minus 3 whole cube plus 6 of minus 3 whole square minus 40 of minus 3 plus 70. So when you'll solve this, your sorry, this is 3, so your answer will come 2. Okay, so this is your remainder, this is your remainder. So there are two methods of finding the remainder. First is by the algebraic division, which we performed earlier, which we performed in the first step, which is a lengthy procedure. And second is by factor or the remainder theorem, in which you just find out the value of x first by equating it to 0, and when we put that value of x in the polynomial, you'll get the remainder. Okay, so these are the two methods of finding the remainder.